Welcome back. We're continuing our series on solving and graphing linear inequalities in two variables. So let's take a look at the next one. We have y plus 1 is greater than minus 2x plus 4. All right, now here we're given an inequality in point-slope form. So let's go ahead and convert to slope-intercept form by solving for y. So let's go ahead and subtract both sides by 1. Those two terms will cancel. So we have y is greater than, we have minus 2x plus 4 and minus 1 is plus 3. And here is our new equation in slope-intercept form, and we're going to use this one from here on out on this exercise. So the first thing we want to do is pick out a few values for x so we can get a few points on our graph that we can connect with the line. So we want to be studious about this, so let's pick out a few simple ones. X equals 0 is always an easy one. So when x equals 0, y equals minus 2x, which is 0, plus 3. Now one more time, we're letting y equals x instead of an inequality because we want a particular value for y so we can have a particular point on our graph instead of having just an interval of points. All right, so y equals just 3, and that'll give us our first point of 0, 3. When x equals 0, y equals 3. All right, let's go ahead and find another one. We have x equals 1. That's a simple one. So we have y equals minus 2x, which is 1, plus 3. Minus 2 and plus 1 is minus 2. Minus 2 plus 3 is just 1. So we have the point 1, 1. And we can graph this from here because we have 2 points, which would make a line, but we want a third point just for a little bit of better accuracy. And so we also have an idea of what's going on the negative side of x. So let's go ahead and, oh, computer's freaking out. X equals minus 1. So y equals minus 2 times minus 1 plus 3. Two negatives will cancel, so 2 times 1 is 2, plus 3 is 5. So we have the third point, minus 1 and 5. All right, now we can go ahead and graph this inequality. We want to look at the biggest values that we have for x and y so we can scale it properly. Here's our y-axis. Here's our x-axis. The biggest value for y is 5, so we're going to make sure we have 5 up here and just write a few on this side. And the x values are fairly small since we picked 0, 1, and minus 1. So let's go ahead and plot these values. First point is 0, 3, which is right here. Second point is 1, 1, occurs right there. And third point is minus 1 and 5. So we have 3 points on our line, so let's go ahead and connect them. Now we need to look and see if we have a greater than or equal to sign. This is just a greater than, so our line is going to be dashed. A dashed line means that we are excluding all the points that fall on this line, just like when we were graphing on a number line. If it was a greater than or equal to sign, we'd have a solid line, which means we would include all the points on the line. So what we're interested in is all the values that are above this line, because we have y is a greater than. So we want all the values greater than on the positive direction of this line. This is below the line, this is above the line. And that's all there is to it. So let's do a few more of these. Remember, we have the tools to do all this. We've done them on a number line, and we've extensively graphed equations and inequalities in slope-intercept form. So now we're just combining what we know to get our interval. So we have our next one is 3y minus 2 is less than 9x minus 5. Again, we have our linear inequality in point-slope form, so let's go ahead and solve for y to get it in slope-intercept form. Slope-intercept form is much easier, I think personally, than any other form when it comes to graphing. So we are adding 2 to both sides, so we have 3y is less than 9x minus 5, and plus 2 is a minus 3. Let's go ahead and divide through all 3 terms by 3. Those 2 terms will cancel, which gives us just y on the left-hand side. All 3 terms are factors of 3, which will make some pretty nice whole numbers here. We won't deal with any fractions. Y is less than 9x over 3 is the same thing as 3x, minus 3 over 3, which is just 1. So we have a nice, simple looking linear inequality in slope-intercept form. So let's go ahead and pick out some values for x. You can keep on using x equals 0. So y equals 3 times 0 minus 1. Again, in our linear inequality here. 3 times 0 cancels, so we have minus 1. And our first point is 0 minus 1. Let's do a few more. We have x equals 1. So y equals 3x. So 3 times 1 minus 1. 3 times 1 is 3. 3 minus 1 is 2. So we have our second point of 1, 2. Let's go ahead and get a third one. See what's going on the negative side of x by choosing negative 1. Y equals 3 times negative 1 minus 1. 3 times negative 1 is negative 3. Negative 3 and negative 1 is negative 4, which gives us our third point of minus 1 minus 4. All right, so let's go ahead and plot these points. This is our y-axis. This is our x-axis. Most of our points are going to be in the negative direction. It's negative 5 down here. And 1, 2, 3, 1, 2, 3. Okay, so our first point is going to be 0 minus 1, and that's right here. Second point is 1, 2, right here. Third point is minus 1, minus 4, which is right here. We have 3 points, so let's go ahead and connect them with a line. The first thing we need to look at before we do that is our sign. We don't have an equal to sign, we just have a less than sign. So we're going to have a dotted line or a dashed line. That means we're excluding all the points on this line. We're not including them in our solution set. So we have keeps going in both directions, not including any point on this line. We only want all the values that are less than the line, so we're shading under the line. So all the values underneath the line satisfies or is in our solution interval for this particular linear inequality. All right, let's go ahead and do one more. Fairly straightforward. We should be very comfortable with this by now. Let's say we have 1 minus y is greater than or equal to a minus x. Okay, again, we have a linear inequality in point-slope form, so let's go ahead and solve for y to get it in slope-intercept form. Let's go ahead and subtract both sides by 1. Those two terms cancel, so we have minus y is greater than or equal to minus x minus 1. Lots of negative signs, but the good thing is we can divide everything through by minus 1 to get this y out front to a positive y. All these negative signs will cancel. It's going to leave us with a very simple looking slope-intercept form. The only thing we want to remember is to flip our sign because we're dividing through by minus 1. So we have y greater than or equal to becomes less than or equal to, and we just have x plus 1. All right, so this should be very simple. Let's pick out a few values. We have x equals 0. So we have y equals 0 plus 1, and that's just 1. So our first point is 0, 1. Let's get our second point. Let's just let x equal 1. So we have y equals 1 plus 1, which should be 2, giving us our second point, 1, 2. Now let's go ahead and just find a third point. Let's not get fancy with it. Let's just get x equals minus 1, so y equals a minus 1 and a positive 1, which gives us 0. So we have our third point of minus 1 and 0. All right, 3 very simple looking points. Let's go ahead and get a rough sketch of the graph. Here's our y-axis, here's our x-axis. Okay, so our first point is 0, 1. That's right here. Our second point is 1, 2, right here. Our third point is minus 1, 0. Let's look at our sign. We have a less that we're looking at our slope-intercept form sign. We're done with this one. So let's go ahead and that's another reason why we put it in slope-intercept form. They're much easier and more simple to graph. Y equals, so y is less than or equal to. This is going to be a solid line because we're including all the points on the line. So we're going to have a solid line, and we're going to imagine that it connects all these 3 points. No, it's not very pretty. Continues in both directions infinitely. And we want to shade all the values that are less than y. We're including all the values less than y, so we're shading underneath the line. We want all these values. All right, so not a whole lot to this. I believe we'll do a few more. Well, actually, in the next section, we'll look at an application of two variables and a linear inequality. So look over these a few more times. We should have a good handle on this by now before we move on to the application. So I'll see you in the next video.